Welcome to The Explainer. So today we're talking about something pretty wild in the fight against Alzheimer's. The idea that we could use light, of all things, to help the brain clean itself out. It sounds like sci-fi, but stick with me. Let's dive in.
Okay, first things first, let's get a sense of just how huge this problem is. We're talking over 50 million people worldwide living with Alzheimer's, and that number is from a few years back. It's just a massive global crisis, and for so long we've been hitting a wall trying to find treatments that actually work.
So, to get why these new ideas are so exciting, you gotta reframe how you think about Alzheimer's. It's not just about memory loss. At its core, it's a physical issue. Think of it like a really bad plumbing problem, but inside your head. And the main culprit in this plumbing problem? It's this protein called amyloid beta. Normally, your brain just, flushes it out. No big deal. But in Alzheimer's, it goes haywire. It starts to misfold, get all sticky, and clump together into these nasty plaques. This is the toxic gunk we're talking about. It literally clogs everything up, jamming the signals between brain cells. And that's what causes all the devastating symptoms. Okay, but here's where the story takes a fascinating turn. Our brains are not just sitting ducks. They actually have their own dedicated cleanup crew, a system designed specifically to handle this kind of toxic waste.
It's called the Glymphatic system. And get this, we only found out about it in 2012. I mean, how crazy is that? It's basically this whole network that runs alongside our blood vessels, acting like the brain's personal sanitation department. And it's absolutely vital for keeping our brains in good working order. And the way it works is just genius. It's like a nightly power wash for your brain. While you're sleeping, clean fluid, that's cerebral spinal fluid, gets pumped in. It washes through all the nooks and crannies of your brain tissue, grabbing all the waste, including that nasty amyloid beta. And then, whoosh, it flushes all that junk right out.
So what's going wrong in Alzheimer's? Well, pretty simply, this amazing cleaning system starts to fail. The cleanup crew gets sluggish, I guess. They stop doing their job right, and that toxic gunk just starts to pile up, day after day.
And we can actually track this breakdown happening. It's not random. The plaques don't just pop up everywhere. Nope. They start building up in these really specific, deep parts of the brain first. It's only later on, as things get worse, that the gunk spreads to the outer layers, the parts that handle our higher thinking, our memories.
And this is the real kicker. The path that this toxic protein takes as it spreads, it almost perfectly maps onto the brain's natural drainage pipes. It's so ironic. The very system that's supposed to get rid of the trash becomes the superhighway for the disease once it gets clogged.
So, if the problem is basically a clogged drain, that's led scientists to a really out-of-the-box idea for a solution. Something that isn't a drug you swallow, but a beam of light.
I know. It sounds completely like something out of Star Trek, right? How on earth can a little bit of light fix a clogged brain? Well, it turns out there are a few really cool ways it might actually work.
The fancy name for this is Photobiomodulation. Let's just call it PBM. The whole idea is to shine specific kinds of light, think red or near-infrared, onto the head. This light can actually penetrate the skull and give the brain cells a little energy boost, kind of like jump-starting a car battery. The goal is to wake up the brain's own cleanup crew, all without a single incision.
And what's really cool is that this isn't just a one-trick pony. The light seems to launch a multi-pronged attack. It fires up the mitochondria, the little power plants inside our cells. It wakes up the brain's immune cells and tells them, hey, go eat those plaques. And, most importantly, it helps get that cleaning fluid flowing properly again to, unclog the drain.
And listen, this is not just some wild idea in a lab. We're talking about real-world application. There's a specific therapy, using light and sound, flickering at 40 times a second, that's 40 hertz, that's shown so much promise it's already in phase 3 clinical trials with actual people. That's the final step before it can be approved.
Okay, so this is all incredibly exciting stuff. But we gotta pump the brakes a little. This isn't a miracle cure just yet. There are some really big challenges that scientists are still trying to figure out.
And the number one enemy here? It's just basic physics. Our skull does an amazing job of protecting our brain, but that means it's also really good at blocking light. And since Alzheimer's starts way down deep in the brain, just getting enough light to the right spot is a massive problem.
So how tough is it? Get this. Some studies show that less than 3%, 3% of the light you shine on the head makes it just 3 centimeters in. That's not very far. It's like trying to light up a basement from the attic.
But, scientists are clever. They're already working on some really creative ways to sneak past the skull. They're trying things like shining light up through the nose to reach the bottom of the brain. And even more futuristic stuff, like injecting tiny molecules that only activate and destroy plaques when you shine a light on them. And let's be real. The reason we need these new ideas so badly is because the old way just hasn't worked. We've thrown, over $600 billion at developing drugs, and more than 95% of them have failed. Flat out failed. That level of frustration is exactly why a physical approach like light therapy is so important. It's a completely new and, honestly, very hopeful direction. So, it leaves you wondering, doesn't it? For decades, we've thought the answer to Alzheimer's had to be a pill, something cooked up in a chemistry lab. But what if we've been looking in the wrong place? What if the future of treating one of our most complex diseases isn't in a bottle, but in a simple beam of light?